We're going to discuss about the implementation of k-means clustering for customer segmentation. For this, the equipments required are our personal computer and Anaconda installed in them. The steps or algorithms are: import the necessary packages using import statement, read the given CSV file using read CSV method, and print the number of contents to be displayed using df.head function. Import k-means and use for loop to cluster the data. Predict the cluster and plot the data graphs. Print the outputs and end the program. The program begins by importing the necessary libraries and loading the dataset mall_customers.csv into a pandas data frame. The .head function and .info methods are used to inspect the first few rows and summary information of the dataset respectively. The additional function and .sum function method checks for any missing value in the dataset. A for loop iterates from 1 to 10. Each iteration represents a different number of clusters for k-means. Within the loop, k-means is instantiated with n clusters equal to I and k-means plus plus, a method for initializing centroids to speed up the convergence. The algorithm is then fitted to the data using k-means.fit function, and the within cluster sum of squares is computed and appended to the WSS list. After computing the WCSS for different number of clusters, the code plots a line graph using matplotlib to visualize the relationship between the number of clusters and WCSS. This graph helps to identify the optimal number of clusters by looking for an elbow point where the rate of decrease in WCSS slows down significantly. After computing the WCSS for different number of clusters, the code plots a line graph using matplotlib to visualize the relationship between the number of clusters and WCSS. This graph helps to identify the optimal number of clusters by looking for an elbow point where the rate of decrease in WCSS slows down significantly. Based on the elbow method, the code selects n clusters equal to 5 as the optimal number of clusters. A k-means model is instantiated with n clusters equal to 5 and the algorithm is fitted to the data. Predictions are made to the dataset using kilometer.predict function to assign each data point to a cluster. The code creates a scatter plot to visualize the clusters based on annual income and spending score 1 to 100 features. Each cluster is represented by a different color on the plot, making it easy to distinguish between them. Finally, a legend and title are added to the plot to provide clarity and context. The output of the given code represents the dataset and dataset information and the elbow graph WCSS versus each iteration method and the cluster representing the customer segments graph. Thus, we have developed an k-means clustering for customer segmentation using Anaconda.